Hello, let's draw a simple triangle on Plunker Playground. plnkr.co. You need to log in. You will see this page. You need to click Sign Up and choose, for example, GitHub, Google, and so on. After this, you can log in. I will use GitHub. Now click New button, JS button. Let's delete this folder. We see document type HTML. We will delete this. Select it and press Shift Tab. Shift Tab. Delete this and write canvas tag, begin tag and end tag. Write here ID, render canvas, size, width and height. Let's add title. Example, create tag script. Get canvas. Canvas document get element by ID. We get this. We need to get this element canvas by its ID. Render canvas. Now canvas is here. Let's open debug console using Ctrl-Shift-J and run application. We will see canvas output here. This canvas ID, width and height. We can clear console using this button or Ctrl-L. Let's get context. Canvas get context. WebGL. Let's set color. GL clear color. Gray color. This is RGB. Alpha. GL clear. We clear a canvas with this color, bit buffer. Let's see. We don't see anything because we have clear code with no buffers or bitmap. Yeah, I made a mistake. Color buffer bit, not bit buffer. We see a color. We can set, for example, with red color, for example, or I will keep it gray. Clear it, and let's create a shader. vertex shader and fragment shader. Const vertex shader source. Type these two symbols. It is where is tilde in left top corner of your keyboard. Type input attribute vector 3a position. We will get position to this variable from vertex buffer object. Type main. It is a main function that will be called for vertex shader. In vertex shader, GL position, it is a variable to set a position. We will use constructor vector 4 because this GL position variable requires it. It is has a type vector 4. A position has type vector 3. A position. And in this case we need to add this variable, and don't forget to type 0.0. It is necessary for in shaders. It is our fragment shader. It will be called for every position in vertex buffer object. I will say about it later. Tab. Let's create fragment shader source. Type here void main gel frag color. It is a color for pixels for fragment. Vector 4, it has vector 4 too, and RGB color. For example, let's set it to green. Don't forget about the 0.0 and alpha channel. It must be 1. Let's create shader. Const vertex shader gel create shader gel vertex shader. Let's add source shader source type what source we need to add, in what shader we add the source, and we need to add this source to the vertex shader, to this vertex shader. We set vertex shader here, and we need to write vertex shader source. We add a source to compile. Now let's compile. Compile shader vertex shader, and let's see a result of compilation. GL get shader info log. Shader info log. Vertex shader, and here what type? Compile status. Yes, and we need to console log pass it here, and let's try to run it. We see we don't have errors. If we, for example, change vector 4 to vector 3, we see two arrow constructor, this constructor vector 3, too many arguments. Okay, it is 3, but we pass 4. 3 plus 1, 4. Cannot convert vector 3, this vector 3, component vector to float, offload to position, this position, high p for component vector, this for component vector. It is an error. Okay, it works. Let's to copy this for fragment shader and change fragment shader to vertex shader to fragment shader, fragment, and let's change here fragment, copy it, and set it here. Now we fragment shader, create fragment shader, we add source, this source to fragment shader, we compile fragment shader, and we print output of compilation fragment shader. Let's see. No errors. Let's add error to check if it works. Yes, it works. It's fragment shader medium p f component vector. So it's the same like before. It's vector 4. We try to use this constructor with 4 arguments. It's okay. Now we compiled 2 shaders, but we need to attach these shaders to shader program. Const program GL create program. We need to attach shaders, attach shader to program, to this program, and vertex shader, and we need to attach fragment shader, and we need to link GL link program. We need to link, and let's to check console log, and like here we use get shader info log, but in this case we will use get program info log. We need to set what program we will check, and GL link status link status, and try to run it. We see we don't have errors. Let's to avoid printing empty strings, let's print it only when we have an error. Let OK GL, we will create a bool variable, get shader parameter, and set this. Okay, if we printed, we will see get shader parameter. Only one represented. Get shader parameter. So I forgot how to use it. Let's see a documentation. It is shader and parameter name. What is parameter name? The list of compile status shader type. Okay, we need to use compile status, but I think, and this, here we need only shader. Yes, we don't need compile status here. And get shader parameter. Yes. Now let's try it. True. It is not. It is means that compilation is without errors. For example, if we set it, we will see false. Okay. So we have OK status. If not OK, we will print this. So the same for this. Let's copy this, but here we need to change to fragment. If not OK, and let's delete this. Compile status, good. Next, we need to make this get program parameter program and link status. If not OK, we print this. Let's see. Shader is not compiled. It is this was printed. It's because I forgot to fix it. Yeah, it works. We have a program. We will work with this program. We don't need shaders. We need it, but they was uploaded to this program, and now it is on the after running. These shaders will be inside of video card, and we will use program to work with shaders. Let's create a vertex buffer object to upload our vertex positions of our triangle. Let's create vertex positions. Okay, we will have we have canvas by default 0 0 0 x y z 0 in here in the middle, in the center of the canvas. here is 1, here is 1, -1, this -1, this -1, y -1. Okay, so we need to draw a triangle. We will set this vertex, and this vertex. This vertex is minus 0.5 and 0.5 for y. 0 minus 0.5 and minus 0.5. Let's set it. Minus 0.5 minus 0.5, 0. It is x, y, z. X, y, z. Next, let's set another vertex. Here will be a vertex with coordinates 0.5 minus 0.5. 0.5 minus 0.5, 0. And the last one is here. We set this, and now this. This will be 0, 0.5, 0, 0.5, 0. We set it 3 vertices. Let's upload them to video card using vertex buffer object, WebGL. Const vertex position buffer GL create buffer. Let's to activate this buffer using bind buffer vertex position buffer. Yeah, and we need to set we need to add GL array buffer. It is target. We bind this buffer to target. It means that we activate it. Let's upload our vertex positions, this array, to this vertex buffer. Buffer data. We can find this buffer GL buffer data and see what parameters it has. Target size usage, and you can see it is target first parameter. It can be array buffer or element array buffer. It is for WebGL 2. Size, we need to set size and usage, but we will not use this constructor. We will use this, the next one, source data, that uses source data. So we skip this, and we will use it doesn't have yes, this we will use this constructor. Okay, first parameter is the same like this. We bind it to this target and we use this target. Here, how many data for first vertex? 3. We set it 3. Here, what is type? It is float. We float. No. Sorry. No, it's okay. Buffer. Here we need to our float32 array, and this data GL static draw. We upload it. It is a parameter. We will not change these elements. In this case, we use static draw. We upload this data, but we use this float to array constructor. It is requires. Let's set up. Let's get this attribute to set up it. Const a position location. We need to get a location. Get a trip location. Program from shader program we get a position. Let's set up it. GL vertex attrib pointer app position location. We need to set up this, and we set up it like this, that this buffer, we uploaded it to buffer, this vertices, but we need to get them from vertex shader. In this case, we need to set up that it is 3. We need to message to OpenGL, to video card, that this VBO uses 3 elements for a vertex. Next is type. It is float. This is false. That means that we don't need to normalize it. And the last 2 parameters is offset and stripe. You can Google this and read about these parameters. We don't use it. Just set it to 0. Enable vertex attrib array. Just to enable it, that we use it. Next, we can draw. We clear a canvas, and after this we need to activate a program. Use program. I think I will move it here. Yes, I think it's better when we get attributes. Before getting attribute, we need to use program. Let's try to draw arrays. GL triangles from 0 to 3, and let's try to. Okay, what does it mean? We call draw arrays and we set 3. It means that we need to draw three vertices. And when we call this, it means that we call vertex shader 3 times. This vertex shader that was uploaded to video card will be called 3 times. At first time, So it knows now that 3 elements, and at first time it will get 3 elements from the array and put it to this variable. In this variable it will be uh, uses to create vector 4 and put it to this, and we set it means that we set a first triangle position. Okay, we have float array. Okay, I have error in this world. Array. Draw arrays is not a function, so draw arrays. Yes, we have a triangle. So at first when we set this position, in the next time, so this draw arrays will call, so after calling this function, we will this vertex shader will be called 3 times. The first time, whereas this data xyz will be passed to this, and it will be set. In the next call, this will be passed to here, and it will be set. And in the third time, this. And we have 3 positions. After this 3 times calling, the rasterization will be made. So in this case, all triangle will be how to say it, separated on little squares, very little squares, like pixels. And this square, this row square, this row, this, and this. It will be array of fragments, array of squares. Fragment can has a few pixels, so it means that it's sometimes it's called a pixel shader. So we will have, after rasterization, empty array of empty squares, and after this, fragment shader will be called for every single square, for every single fragment. So, and for example, for 0, 0 element, and this square will be set to this color, yes, a green color. The next one, next, and every one will be signed with this color, and it's all, it's like it will work. Thank you for watching. Bye.